Let's have a little bit of an introduction to SPSS. So I've gone to File and Open Data, and I have opened this file, Longitudinal Vision Data. It's a pretty large file. It has quite a few variables in it. It's very similar, this layout, to Excel, except that instead of letters being along this top row, you have the names of variables. And we have quite a few subjects here, 14,000, about 500, 14,500, somewhere in that neighborhood. And you can see that for each row here, we have an ID, and we have study year, grades, and so forth. What we're going to do is what we're interested in doing here is setting up frequency distributions. The first thing that you want to do with your data after you've spent some time entering all this information is to kind of look and see what you've got, see what the nature of each of your data are, what the nature of each variable is, what the data look like. And so let's look at how SPSS works. So we have our data screen. We have an output screen that we're going to look at. Now I set my screen up to look like this, to split it between the two. So I have data on one side and output on the other. You can move your windows around. You're going to, when you highlight the SPS icon on the bottom, you'll be able to pick between looking at output or data. There's also syntax and other things you can call up, but these are going to be the two main ones. So in addition to this data screen that shows you all your data, there's also a variable screen which lists all the variables. So these are all we have 45 variables, and you can list the heading. These are the variable names. You can't have spaces in here, so sometimes you're not as descriptive as you would like to be. So for example, we have myopic, and for the label we have myopic at some point, meaning they're myopic at some point during the follow-up period. The kids were followed for various lengths of time. We have value labels that we can put in. So for myopic, we have no, they were never myopic and never during the study, and yes, they were. Same way with emmetropic. We can do that there as well. Okay, so up here we have menu items that let us, there's little shortcut icons here, but the menu items are going to be what you're going to use most. For example, under data, you can sort the cases. For example, let's say we want to sort by ID and study year. It'll then rearrange all the data. And now we start with ID number 2, and we have a couple, and 3, and 17, and 18, and so forth. And you can see how many years we have for each of these IDs. This is just a subset of this data, so there may not be complete data on everyone. So let's go in and analyze our data. There's all kinds. This is the meat of the analysis that we are going to be using. And many different kinds. Under descriptives, we can do frequency, descriptives, crosstabs, various different types of things. Compare means. Next week we'll talk about t-tests, general linear models. After that we'll talk about analysis of variance. We have regression. There's just all sorts of analyses, and we'll talk about many of these. Right now let's go to frequencies. Now when you click on a box, it lets you select the variables that you want to look at. And so let's say we want to know what's the age distribution. How many, under classification, this is each year was a person classified as myopic, emmetropic, or hyperopic. We have general refractive error. That's basically spherical equivalent. We could look at IOP, different things. Maybe we could look at vitreous, anterior chamber, mean axial length, lens thickness. Let's look at some of these. Now, what this will do for us is it will give us a frequency table and for each of these items, but also we might like to have some statistics. For example, I'd like to know the mean, maybe the median, although if we pick the quartiles, we'll get the median because it's the 50th percentile. And get standard deviation, skewness, kurtosis, things like that. We can also put in like the percentiles. The AMA likes, if you're not going to do mean and standard deviation, they like 15th, 50th, and 85th percentiles. They like that because if you think about it, 68% plus or minus, in a normal distribution, 68% of the observations fall between plus and minus 1 standard deviation. Well, 68 from 100 is 32, half of 32 is 16, so this is 15 is close to the plus or minus 1 standard deviation cutoff points. And so that's probably why they chose those numbers. We can do a chart. We want a histogram to see the shape of our distribution. And we can overlay a normal distribution, a normal curve onto that. So let's see what we have here. So it's just done the distributions for this. We'll make this a little bit bigger so you can look at it. This tells us, it's good to check this out to see how much missing data we have. We're actually not too bad on the variables that we figured. We're missing one on what their classification was on myopia. We have all refractive errors. We're missing a few IOPs, that's our worst case, and a few of these basic physical dimensions of the eye. Now, under age, we have age carried out to 2 decimal places, probably actually more than that it looks like, because there we've got 3. We have age carried out to multiple decimal places, so this probably wasn't a very good table to type. It's pretty crazy in terms of its frequency. So I think we'll just come in here and we will just get rid of that guy. And here we have a frequency table on the types of myopia. 1, 2, and 3. And I guess I didn't label those to be printed out, which would have been nice. Refractive error, the same problem in terms of all the minutiae. Really, when you're doing your continuous variable ones, you probably want to, up here under frequencies, in fact, let's do that. Let's get rid of this. All that work. Let's just hit delete. Let's go to Analyze, Descriptive, Frequencies. Let's check this box, uncheck this box, and not show our frequency tables. So we're just going to get graphs. So here's age. Notice our age isn't very normally distributed because we've truncated our sample at just a little bit over 5 years. And it's just mostly kids in in grade school that are signed up and junior high school as they get followed up. So not very normally distributed. What kind of curve is this in terms of, would you say it's skewed? It's not very skewed. This is pretty evenly distributed. Would you say it's a little, we wouldn't say it's normally distributed. We have a big empty space here. This is getting closer to the uniform distribution, and so it's flat in terms of kurtosis, kind of flat. So it's platykurtic. Here we have the classifications. Now there's really only three. That gets a little confused on its scaling. We have 1, 2, and 3. 1 is myopic, emmetropic, hyperopic. Remember, kids start out hyperopic for the most part, and they move into emmetropization, and then some don't stop and go into myopia. Here's refractive error. Let's look at this one. So, is this normally distributed? Well, it's a little peaked, more peaked than a normal distribution. And so, whereas age was flat, this has got a steeper peak. This would be what? Let's say leptokurtic. And here we see the mean and standard deviation. By the way, up here, because I failed to show it, we were looking at the missing data, but here are the means, the standard deviation, skewness, kurtosis. So for refractive error, kurtosis is 7.9. For age, it's a negative. It was kind of flat. We have the standard errors for kurtosis and skewness. And then we have our percentiles. I guess I had clicked quartiles as well as the 15th, 15th, and 15th, 50th, which is the median, and the 85th percentile. So you have a nice descriptive description of the data here, as well as looking at the charts. So we come down here, we see what else we have. IOP is pretty normally distributed. Vitreous chamber depth, pretty normally distributed. Same with anterior chamber depth, axial length. Now think about this for a minute. We have myopic children, hyperopic children, and emmetropic children. Yet do you see any breaks in this distribution? No. It's not like myopia is a separate standout kind of a condition. It sort of looks like it's just part of the distribution of values that come out. So let's look back here again. And what is a problem with looking at these distributions like this? Like, look at this nice thing. Well, the assumption is when you look at a population frequency distribution, everybody's independent. But the fact that we have duplicate values on a lot of people suggests that this is in fact not an independent set of data. So what we might want to do is reduce this data set by taking the first value. I mean, we could do it in any different way. We could split it by study year. That would give us a separate analysis for each person. Or we could just do one set of observations by looking at the first one. So what we're going to do is we're going to look at the first observation of every subject, and we're going to do this using the command aggregate. We're going to separate by ID and study year, and then all these other variables we're going to put in down here. We're going to select as the function the first value. We could take the mean, and that would average everybody's values, but we don't want to do that here. We want to look at the first value. We could also take the last, take the minimum, max. We could do a lot of different things. And then we want to create a new data set called first. Say OK. And it's already done it. We go down and click on our SPSS icon, and it brings up now three things: our original data, our output, and something called untitled but first. And so what we have here now is the first observation of everyone. And I see that I made a mistake in that I put in both ID. Let's do this again. Jeez. We want to aggregate. Oops, not on this. We have our longitudinal data. Data. Aggregate. We don't want to add study year because it gives us the first ID and the first study year, which is everything. We just want the first study year, not the first observation of each study year. And it's done it again. And now let's go look at that. Now we see we only have one ID number 2, one ID number 3, one ID number 17. Here we had 2s, 3s, 17. Now we can analyze our descriptive data. And we have to punch in our statistics again. Turn off our frequencies. This time we'll do age is for integer of age. And we'll do a couple of these. Just give you the idea. Charts, histogram. Okay. Now notice over here on our Outlook we have our output. We're not printing anything, we're just saving it. So this is what we did before on the other data set, and this is what we just did on this first data set. Up here, if we come up here under statistics, we can see our N was 14,527. Here we can see, just looking at the first one, we have 3,618. If we look at our integer age distribution now, we're just looking when kids started the program. You can see kids started the first observation. There was actually a 15-year-old that started this study, which is kind of weird. You're not going to be able to follow him very long. But you can see there were a few that were 5, but mostly they're 6, 7, 8, 9, so forth. So we have a skewed distribution of age. Refractive error, still, even at the beginning, it's kind of leptokurtic, centering around just a little shifted to the right of 0. You can look at IOP. That also is pretty symmetric, not too bad on the normal distribution, and it's not skewed, definitely. And the center, the mean, is 17.24 with a standard deviation of 3.7. So let's see, what is for IOP? The kurtosis is 6, so that's pretty close to, not too far off of 0. Skewness 0.362. You think of it like in terms of standard deviation units. Like is 0.36 is a third of one standard skewness unit. 0.6 is 0.6 of one standard unit. We saw up here that we had, for refractive error, a kurtosis of 7.9. That's really high. That's That's like 7 standard deviations away from the mean kurtosis. So that's pretty intense. So that's SPSS descriptive.